what I do.
Okay, do you guys have any questions on what we talked about? Let's see, what was the last one? Was iron or any of the other minerals? I can loan you mine if you need it.
Oh, she's got one. Thank you.
Okay. So our next one is our copper. So copper is one of those interesting ones. It is necessary for iron metabolism. So to make your hemoglobin, you need to have copper. Is necessary for elastin and collagen synthesis. What is elastin and collagen?
Collagen's in your hair and nails.
Is that the only place?
No.
So collagen is going to be the protein that ends up making up scar tissue and that type of stuff. So that's involved in wound healing. Collagen is when you're cooking, let's say if you get a round roast, so part of the reason why you want to cook it and slow with moist heat is so you can melt all the collagen, because that's what makes it chewy, and that's because you have the various quote unquote scar tissue. Elastin is another structural protein. Elastin is essentially, it gets the name because it's kind of like elastic. So this is what you, as you get older, what you are less efficient at making, and that's where you get saggy wrinkles. So copper is necessary for elastin and collagen synthesis. You also need it to make melanin. What is melanin? Have you guys heard of that before?
Yeah, it's in the skin.
So this is the pigmentation. So if it wasn't going to be snowing, Cooper, when you went to the beach, if it was going to be 80 like you're probably hoping for, this is what you would have been making to help. That's naturally to protect your skin from the sun rays. So that's the skin pigmentation. Then you have the myelination of the CNS, is the central nervous system. You guys know what the myelin is?
It's part of the neuron, right?
Right, so this is the insulation that covers the neuron. So without copper, you're not going to get proper formation of the myelination or the myelin. So then it's going to be like where you get those neurological disorders, and you'll have uncontrollable tics and that type of stuff that occurs. So it's almost like a mouse eating through a wire to where lights will flicker and stuff like that. So myelination, or the myelin, is the insulation of the neuron system. And then you also have for, this is supposed to be C, I don't know why I hit S, but red blood cell formation. It's absorbed throughout the duodenum and jejunum, so the first two sections of the small intestine. Copper is one that we can store in the liver. And in the liver, it is with two different proteins that it can bind. One is alpha globulin, and the other one is ceruloplasmin. So this is also the transporter on how we move copper around. Our deficiency is you get weak bones, you don't have very good cartilage formation, and a lot of that has to go to the collagen and elastin. You can get aortic rupture. So where is the aorta? Right, so this is the, so those are the top two portions of the heart, so those will just rupture. And then you can also get the microcytic anemia, so just like iron deficiency, it can also be caused by copper. So if you have adequate iron, so if your hematocrit is okay, but you're still showing low hemoglobin, it could be due to a copper deficiency. And then you can get toxic levels. So with that, you can reduce your hemoglobin and you can get jaundice. So you'll notice your decreased hemoglobin, which is your hematocrit, and your hemoglobin, because your copper ends up competing with the iron. So these are one of those two, the minerals that have those antagonistic relationships that you want in a decent balance. Do you have a question?
Yeah, about copper. I raise sheep, so I know that we can't feed copper so at all, but I know goats can't, like, even at NC State Small Ruminant Unit, they give a copper bolus to the goats. I've always wondered, like, why sheep is toxic to them if like they would need it for some of the stuff.
So there's that interaction between copper and molybdenum. So if you feed too much copper to the sheep, you're going to inhibit your molybdenum, which is another micro mineral that we feed. So there's that interaction that sheep are more sensitive to. I used to know the pathway, and I could, somewhere I got a PowerPoint all on just copper and molybdenum. I'll look it up and see if I can, I'll just shoot it your
Yeah,
way.
they do that.
So that's, and sometimes even with cattle, you can get it. So with copper deficiencies, you also get change in the color of the hair. So you'll have something that's like black, so if you have a black Angus and they have a copper deficiency, they'll look like a red Angus. It'll affect the wool of the sheep. So it'll make it.
With the collagen synthesis part?
Probably.
More melanin for the coloration, I guess.
The melanin for the coloration and the rough texture is most likely due to the collagen synthesis. All right, manganese. So notice that this is manganese, not magnesium. So manganese is also a cofactor. These are all essentially cofactors, but manganese is involved in carbohydrate, fat, and protein metabolism. So it's working with a lot of those enzymes all throughout the TCA in the electron transport chain. So that's why it's affecting essentially all of them. So with a deficiency in manganese, you can get abnormal growth. You get increased fat deposition. So that's because with our manganese, if we're unable to keep the TCA cycle going, we're going to end up causing those carbohydrates. Their byproducts of metabolism are going to be kicked out, and so since we can't process them right there, we're going to try and store them as fat. So that's what the carbohydrates then get, quote unquote, converted to fat. Manganese, it's going to cause a deficiency in this, is going to cause resorption of fetuses. That's if you're talking about more or less mammals. With chickens, it's going to cause the embryos to die. So you're going to get increased early embryonic mortality with our manganese deficiency. So they're only going to grow, I think with manganese deficiency, I'm pretty sure that you'll have more like 7 to 10 day early mortalities that you'll see with those. Milk production. You'll get porosis. So this is affecting our poultry industry, porosis, which is also known as slipped tendon. Have you guys ever see the chickens? So they'll typically be laying and have like their hind leg kind of out to the side, and they kind of, instead of standing on their feet, they'll kind of use their hock or their knee joint to move around. So that's in essence that, what's the tendon that goes through your knee? That slips out of place, and that has to do with the manganese deficiency, so you're more prone to get those slipped tendons. You will have shorter long bones, so you're not going to get the length of the femur. You decrease egg production, hatchability. Like I said, that we decrease hatchability because we end up having more early deads. You decrease fertility, so you'll have a lot more infertiles than you will. Typically in the diets, there's some companies that provide this as, you can provide it as inorganic. There are some companies that sell organic manganese. So where the manganese is bound to an amino acid or a carbohydrate. So because they're bound to an organic molecule, those are supposedly more available for the animal. And that's basically meaning that they're not going to interact with other minerals within the small intestine, so then they can be absorbed. So usually they get cleaved off of the amino acid or carbohydrate, and then the manganese can get absorbed. Typically it's going to be in your trace minerals. All right, another one is iodine. So iodine, its main function is it's involved in thyroid, or the formation of thyroxine. So have you guys heard of thyroxine before? Or your thyroid? Have any family members that their thyroid doesn't work? They need to
My
take.
aunt had like a thyroid cancer or something.
Okay, so she had that surgically removed. Now she needs to take synthetic thyroid. So thyroid is important because this is what's regulating your basal metabolic rate. So typically people that, like throughout my family on my mother's side, everybody has hypothyroidism, so they don't make adequate amount of thyroid. That's just a genetic condition. My siblings, my brother, sister, and I are the only ones that have not gotten any sort, we don't have any signs of hypothyroidism. All of my cousins on that side do. So what happens with that is typically you start gaining weight because you reduced your basal metabolic rate, and you're just always tired and you move so slow. So that's where, at least when my mom got diagnosed with it, you would ask her if she could get you something, and it just took her forever to walk across the kitchen, and it's just irritating. So then that's where you discover that they have hypothyroidism. So then they'll measure, you have T3 and T4, but you need to have iodine to make thyroxine. So iodine is the key component. In 415, we'll end up talking about, you'll know the whole pathway and how we utilize it. It's absorbed within the duodenum and the jejunum. It's excreted in the urine. If you have any deficiency of iodine, you end up getting goiter. Have you guys heard of goiter before?
I've heard of it, I don't remember what it is.
So goiter is essential. Do you guys know where your thyroid is located? So it's in your neck. It's actually like right down here. And so goiters are since it's a gland, the body's trying to make thyroxine. So the thyroid keeps on getting enlarged. So it's sent more thyroid stimulating hormone from your pituitary gland, which is then all of that, because you don't have enough thyroxine, is signaling your thyroid to get bigger and bigger and bigger. And so then you end up looking like some people looks like they have a big softball on the side of their neck. It gets very large. So that goiter is associated with trying to make thyroxine, but if you don't have iodine, you can't make it. So once you get a goiter, you even if you start taking enough iodine, you're not going to get rid of it. The only way you can get rid of a goiter is to have it surgically removed. So a lot of times you'll see, this is going to be more developing countries. There's going to be people with a lot more incidences of goiter. If you watch the Learning Channel, sometimes they have various documentaries on people that they will bring in from various developing countries. They bring them here to the U.S. and exploit them, in my opinion, and then have the doctors remove the goiter. With this, you get decreased growth because you have a decreased metabolic rate, so you can't make the energy. You're also going to get decreased egg production, similarly because of why you have decreased growth. You're going to have smaller eggs. If you have too much, we're going to also see decreased egg production, growth, hemoglobin level. But it's really difficult to get too much. Do you guys know where we get iodine now in the diet? Where you guys meet your iodine requirement from? No?
Water, is it? Something
No?
Water.
Probably a little bit, but that's, have you guys heard of iodized salt?
like- Oh, yeah.
So once we discovered that iodine, especially here in the U.S., that iodine was the deficiency was the cause of goiter. I believe that was in like the 1940s. Congress had, I don't remember which act it was, but that's when they started putting iodine in salt, because that was the way that they can ensure every person was getting adequate iodine, because everybody uses salt. And unless you're specifically seeking out, let's say, sea salt or non-iodized salt, or if you're looking at kosher salt, that's everybody puts salt in their food. So that's why you don't see any goiter in here in the U.S. because of that Enrichment Act. Before that point in time, there was a greater incidence of goiters. And part of the reason why it's not too common to see it in animals is because the salt that we are using at the feed mill, iodized salt. So sometimes you'll have a little bit in the premix, but the iodine requirement is going to be met through that. I've never looked to see if a fish get goiters. All right. Our next one is selenium. Selenium is a very interesting mineral because the government limits how much you can put in the diet. So this is one of the ones that's needed in the least amount. You don't need that much selenium, but many times depending on the phase of the animal, this is like right at the critical state of where you can have selenium. So we limit it to 0.3 milligrams per kilogram, or that's 0.3 parts per million.
Why did the government limit it?
So selenium concentration within the soil is extremely variable. There are some areas in the country that is very deficient, and then there are some areas in the country that are very toxic. So You don't want to be supplementing selenium in the diet if you have corn that came from an area that has toxic levels of selenium. So that's why we are limited, and that's the Delaney clause. So it's to limit selenium toxicity. So if that 0.3 milligrams per kilogram, for the most part, that's going to be limiting the risk of clinical deficiency. But in case you have any crops that are coming from an area that were raised in toxic soil, you're going to still be okay. The main function of selenium is it's part of this glutathione peroxidase. So this detoxifies any of the lipid peroxides or any of those reactive oxygen species that are formed within the cell. So this is where, if you remember when I talked about vitamin E and vitamin C, I said those are antioxidants. The other nutrient that's considered an antioxidant is selenium, because selenium is critical in the formation of glutathione peroxidase. Its requirement is influenced by phosphorus in the diet. So your phosphorus can change the requirement. Deficiencies, these are going to be very similar to your vitamin E deficiencies. So you get muscular dystrophy, you get necrotic liver, exudative diathesis, and mortality. So one of the reasons why this selenium gets so toxic is selenium can replace sulfur in the amino acids. So what are our sulfur amino acids again? Methionine and not lysine. It does begin with a C, and cysteine. So why are methionine and cysteine critical in protein formation? What are they forming?
Bonds in the tertiary structure.
Right, so they're forming the disulfide bonds. So selenium, if you get toxic levels of selenium, and this is primarily coming in as, it will come in as an inorganic selenium, becomes toxic, and the selenium will replace sulfur and the methionine and the cysteine. So if you have selenium replace methionine, the sulfur and methionine and cysteine, what does it do to that protein?
Messes it up.
It messes it up, so we're not able to get the proper tertiary formation. So that results in many issues all throughout our protein functions, and it's not just one protein, it's all of them. But things in this toxicity that you'll end up seeing is anorexia, so the animal will just stop eating. You'll start to lose your hair. Why would you lose your hair? Knowing about how it affects methionine and cysteine.
This is just not only have protein within the eyes, why doesn't it neutralize basically?
Do you know what, where you're going to have, in what protein you're going to have a lot of cysteine and methionine? A lot of cysteine specifically. So that's going to be your hairs and feathers. So for instance, someone that has super curly hair, they have more cysteine making up their keratin, which is the protein that you're making. So those disulfide bonds are making it more curly. And if you get a perm to straighten it, you're breaking those disulfide bonds permanently, and that's why it grows out. You'll get fatty liver disease, and then edema too. So those are, so selenium is one of those ones that is controlled by the government because it's so variable within the soil. I don't remember if I have this next. Here it is. So this is showing the various areas. So you can see anything in black is deficient, all the soil's deficient. So you can see here a lot of the corn belt, Indiana, Ohio, Indiana, half of Illinois is deficient. A lot of our Northern California, Washington, Oregon, Idaho is also deficient. So very low levels. If we were similar to 100 years ago where we didn't move crops all over the world, we would want to make sure that animals getting crops from those areas are supplemented. Anything here with these little dots here, so you can see we're here in North Carolina, South Carolina, Georgia, all this area, we're now on the variable areas. So some may be a little deficient, some may be adequate, so it's hard to say. The Central Plains and Texas, this is all adequate. And then all these little dots, the big dots that you see, those are areas in which it's toxic. So you can see really the East Coast, Midwest, we're okay, but even you looking through, so we have Nebraska, Wyoming, Colorado, especially Nebraska here, a lot of corn's grown there, a lot of soybean. If you're in the northern part, you're going to have toxic levels, so it's hard to really know where everything's coming from. You got a question, Cooper?
Well, I was just going to add, there's something about the Atlantic Ocean that's different from like the Gulf or whatever. It seems like everything on the Atlantic side is like really deficient. And like even on the Pacific, part of it's deficient, but part of it's fine.
Honestly, I'm going to say it's more the mountains. This area is covered by a glacier at one point in time, right? We have the mountains, what is this, Blue Ridge Mountains,
Yeah.
the Appalachians. Here we have
Right.
the little bit, Rockies are more, I guess, Rockies here, and then we have the Sierras. A lot of volcano over here. So my guess is it has more to do with the glaciers that went through the central portion of the U.S. that as volcanoes, etc., rain, it washed it all into here and it just kind of stayed here, is more of my hypothesis as to why the central area of the U.S. is more prone to that. I don't know why here in, what's that, New Mexico and Arizona, why we have it, a big deficiency there. The only thing that I can think of, where's the Grand Canyon and where the big asteroid hit? Isn't that more up north? I don't know. So. Any questions on selenium? Our next one is zinc. Zinc is another one of the metals. It's a component of what we call metalloenzymes. So these are enzymes that bind metals. So that should hopefully make sense. It's necessary for DNA and RNA synthesis. Where have you guys probably heard of zinc in your, that would probably be Bio 183, maybe genetics?
That's in sunscreen, but
Well, thinking molecular, not sunscreen.
just like that's where everybody can find.
Do you know how it's involved in DNA and RNA synthesis? Have you guys heard of zinc fingers? So it forms the zinc fingers, which is part of the way in which we are, our DNA and RNA synthase makes our DNA and RNA, so they kind of hold everything together. It's also part of various digestive enzymes, similar to how copper and iron work with the hemoglobin. It's working with these various digestive enzymes. It works with insulin, so it helps for proper insulin utilization, formation. Our absorption is extremely variable. So it ranges from 5 to 40%, and that depends on the form. So if you are talking about zinc sulfate, so typically in the diet you're going to have zinc sulfate, zinc oxide, zinc chloride. Out of those inorganic forms, zinc chloride is the most absorbable, zinc sulfate is the least absorbable, and oxide is intermediate. So that's why you have such a great variability, because it all depends which form it is. You can also get zinc as a organic molecule, organic trace mineral, and that's gonna, typically they have it bound to amino acids. And I think pretty much almost every feed additive company makes a organic zinc. So there's one company that's their primary product. So Zinpro, they make organic zinc. But I believe DSM, Novus, Canon, Alltech, they all have their own organic zinc products. Deficiencies, you're gonna have, you need metallothionein to absorb it. So metallothionein is going to pull it out of the intestine, put it in the blood. Deficiency, you get decreased growth, anorexia, you get hyperkeratinization. Do you guys know what that is? So this is, so hyper is more, right? That's what that means. Keratinization is the making the protein, the structural protein. So some, like if you were, it almost makes it look like with people that you have like permanent goosebumps. So it's like parakeratosis. So you get this hyperkeratinization. It reduces egg production and hatchability, and if you're deficient in zinc for poultry. Similarly toxic, so whether you end up going the two different sides, you're going to reduce your growth. You'll get exudative diathesis. Do you guys remember what that is? When I talked about it with vitamin E, what exudative diathesis is. So this is essentially where you get a bunch of fluid in your extracellular space. So it ends up being essentially a bunch of plasma. Instead of being in your blood, you just get this buildup of fluid around in the extracellular space. So it ends up to where it's like you can go and push on an animal and you would still have your finger indentations would still be there, because it's almost like those, I'm trying to think, like Play-Doh type things, to where you push on it, it's gonna stay. So that's extra fluid and in the extracellular space. And then you get muscular dystrophy if you're toxic also. So if you guys don't understand some of the terminology related to the deficiency or toxic, like you need to stop me and say, what is this? So I can tell you. So this is, I think I showed you this before, but so mineral metabolism can be quite complicated. We have many synergisms and antagonisms. Some things work well together. Some things are going to inhibit each other. So here we have, here's our.
So calcium and phosphorus would inhibit each other?
They do, because they negatively interact. So that's where if you feed too much calcium, you're going to inhibit your phosphorus. You feed too much phosphorus, it's going to inhibit your calcium. Here we have our molybdenum and copper, right? That's what you're going to have with your sheep. So if you feed too much copper, you're going to inhibit your molybdenum. So that's just showing how, although I've stated all these things and make it sound really simple, it's a very complicated interactions that we're playing with. So we want to have a decent balance. And if you get them messed up, you can really mess up an animal. So you can get edema, ascites, the exudative diathesis. So and those things are relatively generic. They could be an indication of some sort of disease state, or it could just be a nutritional factor. So normally if you're seeing a whole, this can be the tricky part, if you have a whole flock of birds that end up having something like this, I'm going to point more to it's a nutritional thing. If you just have one or two, that's probably more related to some sort of disease. Because a lot of times if you have like the ascites, that's not necessarily caused by some bacterial infection that everything's going to get ascites. That's just that bird had liver failure, which is causing ascites, or heart failure that's causing ascites. But if you have a whole flock, that's more indicative that is a nutritional component. Now you got to figure out what's the most likely thing. All right. We talked about this a little bit before, but I'm just going to do a quick review of proximate analysis. So we've gone over now all of our general nutrition that we've been talking about. So how do we evaluate these components in the diet? One is we do proximate analysis. So proximate analysis is where we're breaking up and looking at how much of a product is carbohydrates, lipid, protein, fiber, and ash. So here, this came from Claising, 1998, and he looked at the composition of various feed ingredients. And so if you have any vertebrate, right, so this is going to be your meat and bone meal, poultry byproduct meal, anything that's coming from that, you're going to see then a little bit of lipid, digestible carbohydrates, what's the fiber, that little line is ash, and then, it's not the best picture. Here you can compare to nectar. Nectar is pretty much all digestible carbohydrates. Your grasses, you're going to have a lot of indigestible fiber, some digestible carbohydrates. Our cereal grains. So this maybe protein. I gotta figure out, it's not as clear having stolen it from the paper. I'm gonna remake it. So you can just see how things vary depending on what your ingredients are. So how do we determine that? We do proximate analysis. Proximate analysis is a very old method, so we've been doing it they started in the 1800s, middle 1800s, and this is a starting point to get an idea of what's in the feed. Our main thing that we're going to look at initially is looking at moisture content. As fish and poultry nutritionists, we're not as concerned because a lot of the things that we are feeding is about 90% dry, so we are going off of, we feed as an as-fed basis. We also have our crude protein, which I always abbreviate as CP, and this is looking at protein and non-protein nitrogen compounds. So that kind of goes with the melamine that we had talked about when we were talking about proteins. Our ether extract, or EE, that's measuring fat. So we basically boil the feed ingredient in ether, and ether is going to pull out any fat, and then you dry it off, and whatever's left over is the component without the fat. You have our crude fiber. This is, in theory, looking at cellulose, any lignin, fibrous carbohydrates. Our ash is looking at total minerals, and then we have our nitrogen-free extract, which we do by calculate. We do analyses for all of this stuff. Anything left over we call nitrogen-free extract. So that, in theory, should be our starches, sugars, soluble carbohydrates. What is the thing that we're missing off of this table as far as nutrients go? What nutrient class is missing? Vitamins. So you can't use proximate analysis to measure vitamins.
Why is that?
When proximate analysis was first discovered, or we didn't know what vitamins were. A lot of these things we're dealing with organic chemistry, and we end up breaking up the organic molecules. So typically, if we're going to look at vitamins, you need to do HPLC or liquid chromatography, LCMS, so liquid chromatography mass spec. If you guys are into like cop detective shows, and they'll be like, we're gonna throw this on the LCMS, and then 20 minutes later they have to, oh, it was this compound, and that was the poison that killed her, and that takes 3 months for them to figure that out. It's not 20 minutes like the show makes it seem.
I was wondering, I know what you're talking about. I was like, man, that's quick.
No. You have to have an idea of what you're dealing with before you can throw it on one of those. So.
I'd say they got the new one, I guess.
Power of television. So that's how you have to determine your vitamins. So water, we end up, you cook it 95 degrees for 24 hours. You can do 60 degrees for 72 hours. The important thing is we don't want to completely burn it, right? We just want to get the moisture out. So the way I was taught was 95 for 24 hours, but here many people in Scott Hall, they do 60 degrees Fahrenheit for 72 hours. Then you simply weigh it afterwards, so you get the original weight minus your final weight divided by your original weight, multiply that by 100, and that's going to give you your percentage of dry matter. You do subtract it from 100, that's going to give you your water. Crude protein, this we use Keldol, and so you end up finding out the nitrogen component, you multiply it by 6.25. And that's giving you, so you take your nitrogen by 6.25, making the assumption that all nitrogen is 16%, or all protein is 16% nitrogen, and so 100 divided by 16 is 6.25, and then you do this. Another way that you can determine crude protein is with LICO. Once we get our LICO working again, I'm going to have Dr. Hamon show you. He's the one that shows the LICO, and with our samples that we collected from our little experiment, we can get the results of the LICO. But it's two different ways, is the Keldol and the LICO. It gives you the same thing. Ether extract, you end up refluxing it in ether, so it's kind of boiling it in ether, and then you dry it for a day because we want all the ether to evaporate. We weigh it, and then we get our dry matter weight minus our ether extract weight divided by the original weight, and that gives you your, multiply it by 100, and it gives you your fat percentage. So main thing, ether extract is measuring fat. Our fiber, so this is an old method, so they boil it in acid, and then they boil it in a base. So they're trying to simulate, so back in the 1800s, this is their idea of what the stomach did. So you boil it in acid, and then in the small intestine you have a bunch of either bicarb or that's more basic. So then they boiled it in alkali, and so if it was able to survive the acid and the base, then it must be fiber. And that's why we call it crude fiber, because it's not actually measuring fiber, it's just measuring what could not be broken down by acid and base. I don't remember the acid that you boil it in. So our ash, we end up doing it separate from our crude fiber, but you take this and you put it in a 600 degrees Celsius muffled furnace for 24 hours. So this makes everything, turns everything into ash. It cooks off all organic matter. The only thing that's left over is the individual elements. And then you can weigh that, and you get your ash weight divided by your original weight. So it's the original weight minus ash weight divided by your original weight multiplied by 100, and that gives you your ash percentage. And our nitrogen-free extract, so this is where we're making the assumption. So some of the downfalls of our approximate analysis. So our carbohydrates are determined by what's left over. So you have 100%, you subtract out the water, the crude protein, the ether, the fiber, the ash, and then you get your nitrogen-free extract or your carbohydrates. Your digestible carbohydrates is what NFE stands for. And I think, so some of the limitations. Crude fiber, we're not, anything that's not dissolved, we're assuming is indigestible, and that may not, that's not necessarily the case. We have some fibers that are able to be digested, you have others that are not. Nitrogen-free extract, doing that by the subtraction, we're making a lot of assumptions. So one is that some of our hemicellulose and lignin can actually be dissolved in the weak acid and base, but reality is they're indigestible. So we can look and do this Van Soest. So this is this was determined in the mid, I think around like 1960s they started doing this. So you do the acid detergent fiber. So this gives you this one is giving you all your fiber, so your cellulose, lignin, silica, or your cellulose and lignin, and then our neutral detergent is giving you the heavy cellulose and pectin. So there's the neutral detergent fiber and the ADF are better than crude fiber. I think that's all. Guys have any questions on that?
Is that a 415 class next semester, or?
I have it online next semester if you want. I teach it in the spring in class, so you have your choice in the spring. You can take it online or you can take it in class.
Okay.
If you want to take it online, then you can take it any semester. I teach it in the summer, I teach it in the fall, I teach it in the spring online, but in class it's only in the spring.
Okay. Do you think during the summer it's a lot, or kind of too fast, like, do you?
It is a lot.
Okay.
So it's about 30 hours of lecture that you go over in 10 weeks. I mean, it's not unreasonable, but if you're here and you have questions, you can always just come and talk to me anytime about it. But there, where I glazed over here, what zinc does, we get deep in the weeds on all of that stuff and the metabolism associated. So that class is more of a true metabolism class.
Okay. Well, I think I'm gonna take it.
Good.
Maybe not this summer, but.
I'm clearly biased. I think it's a great class, but it's also my class, so.
Y'all have a good